Okay, we're gonna go through a few examples on definite integrals. My plan for today is to go through these questions. Then you can see the homework here already. Try them. Then after that, if I have enough time, I will go through. Yeah, I should have enough time. I will go through with you a new concept, which is the definite integral gives you the area under a curve. Okay.
Okay.
Yeah, and I think you went on. We didn't have lesson last week, so I think you haven't submitted the homework yet, is it?
I think I did the.
Or did
I did the. Yeah, you marked it already.
Oh, I marked it already. Oh, did I go through already?
Exercise 18, part 1. Exercise 18, part 2. Exercise 18, part 3.
Oh, right. Oh, most of them were correct. Correct. Yeah. Oh, I went through them already. Is it not? Let me see. Hold on. No. Oh, I haven't went through those questions. Should I go through those instead?
I mean, I'm okay with anything.
Okay, then then I think I'll go through those questions first.
I think I'll change device to join the Zoom.
Oh, okay.
I join right now with my other thing because this one's gonna die.
Okay.
I think okay. Yeah, okay.
Recording in progress.
Okay, yeah. Thanks.
Okay.
Sorry.
Yep. Okay, I just changed the share screen to the other one. Let's see. Okay, so which one do you get wrong? Let's see. Question 21 for one of those three. Exercise 18.1, question 21. Let's take a look at this. Question 21, part 1. We want you to differentiate that expression. Okay, you got the right answer. Good. Square root of cube, square root of 2t plus 1. Then what happens next? We want you to integrate this guy. Okay, realize something. Is it exactly the same as the derivative? I mean, as the answer you got here? Exactly the same?
No.
No, definitely. So here is the trick you need to do. What you should have done is to look at this, realize that this is power, actually, look at the previous line, power 3 over 2 and power 1/2. But the base, what's so special about it?
The base is the same.
So that means that you have higher power, lowest power, always factor out the lowest power.
Lowest power.
Yeah, which is what I did over here, 2t plus 1, the same base. But you factor out the lowest power, which is 1/2. This means that you end up with 2 over 2 instead. And here, for the other term, it will be a plus 1. It will be a plus 1. But 2 over 2 cancels away, which will give you power 1. So you can just drop the power. So you're left with 2t plus 1 plus 1, which is
2t plus 2.
Yeah. Then at this stage, is it exactly the same already? Still not yet. So you still need to do one more step, which is to distribute. This square root 2t plus 1, you distribute into each of them. You end up with this expression. At this stage, you realize it is almost exactly the same as what you need already. What do we need? Integral of t times square root, whatever. So here you have t times square root whatever, 2t plus 1. But there's an extra factor of 2. Is it okay to have an extra factor of 2?
Yeah, let's take out the 2.
Exactly. But then on the other side, you still got this guy.
2t plus 1 square root. Square 2t plus 1.
Then how? Oh no. Don't worry. This one, can we integrate?
Yeah.
Can, right? As long as the inside is not sorry. As long as underneath the square root, we have a linear expression. In this case, 2t plus 1 is linear in t to the power of 1. We are able to integrate this safely. Okay. So one more thing I want to bring up is that there's a mistake you made, which is quite serious over here. I think what you did was Let's see. What do you do? I forgot what you did already. Let me take a look. First mistake here. Dx, not correct. The function is everything in terms of t, right? And there's an integral dt.
dt. Okay,
So
okay.
it has to be a t. That's a first mistake.
Yeah.
Okay, has to be t. What other mistake did you make? When you try to integrate this guy, this is correct. However, what you did next was not so correct. What were you doing? What were you doing over here?
What was I doing over here?
Integral of this guy power half. Oh, sorry. Actually, you are correct. Sorry, I have to make a correction. Yeah. No. This is correct. You were integrating it independently, but of course, changes to a t, huh? Okay, slightly wrong. But for the second term, this one not so correct.
Where I'm confused by my own thing.
Yes, I am also quite confused. I think what you did was you see a t, then you factor it out, is it? Can I guess, is this what you did?
I don't know. I really don't. I can't remember really.
Okay. I think this is what you did.
I'm
You
confused.
factor out a t, then you integral 2t plus 1 dt, right? Okay, this one should be t. Then after that, you realize, oh, integrate 2t plus 1. I just did that above. So it must be t multiplied by the answer I did. I got above, which is 1/3 times of the base 2t plus 1. Then you add 1. But of course, sorry, this one should be divided by 3/2. So times the 2/3. But then because of the 2 over here, right, you need to use chain rule. So you times half. Right? I think this is what you did. Then the 2 and 2 cancel away. So you're left with t times, what is it? 1/3 2t plus 1 to the power of 3/2. Then you bring the t on top. So t over 3. Is this what you did?
I genuinely do not remember. But I mean that sounds like what I did.
Sorry. Yeah. Okay, so here, can you see what's the mistake? What's wrong with this working? It looks very logical, right?
You cannot bring out the t.
Yes, exactly.
Yeah.
Here, first line wrong already. You cannot factor out a variable. What do I mean by variable? I mean with respect to the d something. This guy tells you the variable. T is the variable. So whenever you have a factor t here, which is a variable, you cannot factor it out. Okay? Okay, good. So yeah, that's why this line is wrong. What you should have done instead is to realize, oh, after you do some factorization and then you multiply it in, you get this expression here. So that means that the derivative of that ugly looking expression will give you this sum of two terms. Then, of course, I hope you remember integration is the reverse of differentiation, so you can work backwards, right? So that means that we get integral of the sum of these two terms, gives you back the original expression you are trying to differentiate. But then integral, when you have two separate terms, you can sort of distribute the integral. Okay, it's one of the properties of the integral. So you can integrate this guy plus integrate the other guy, but make sure it's always dt. Okay, so over here, you have to make sure that the snake symbol, the integral symbol, is paired with a dt. And then something in between. Okay, they come as a pair. You cannot drop the dt. So likewise for the second pair, integral and dt. But I skip a step? The 2 I factored out. The 2 I also factored out. Is that okay so far? So from here, this integral you can calculate, right? 2t plus 1 to the power of half. Just add 1, get a new power, divide by new power. Actually, you just did it. You already did it. Oh, but don't forget a factor of 2. Then this guy here is what you're trying to solve. So you just need to make this the subject. So what I would recommend you to do is calculate this yourself, multiply by 2, then bring it over. Then after that, you got 2 times of your subject. So after bringing over, then you divide by 2. Bring over, then you divide by 2, or times half. Okay? I'll leave you to solve it on your own. Can?
Yeah.
You can? Good. Good. One more thing. Yeah, over here I already mentioned. Never multiply both sides of an integral by a variable. Oh, right. Oh, is that what you were doing? Let me think. Maybe what you are doing over here is you integrate square root, then you realize it's 1/3 something. Then you go from here to there, you multiply by a t. So here to there, you just multiply by a t. That's also not okay. Okay, you cannot just multiply by a variable. What is a variable? It's with respect to the d something, the letter you see over there. In the future, you will learn about what's called partial differentiation. Ooh, it looks like this. You have partial f over partial x, partial f over partial y. Your f function usually is fx equals something like x cubed. Now it will you have to introduce an extra letter, comma y, and then plus y squared, for example. Then you have to do what's called partial differentiation. It is not in the syllabus, not in H2 Max as well. So I am not going to be discussing about it. But if you're doing engineering math, straight away need to learn. Okay, not yet. So in that case, when in the future, what you need to really understand is that when you're doing an integral, or in the future you'll be doing double integrals and triple integrals, by the way. But not now, not yet. What you really need to understand is that this letter is very important. It represents the variable. Not to be confused with a constant. Okay? Constant can factor out of an integral, but variable, you cannot. Clear so far?
Yeah.
Okay, good. Okay, what else did you do wrongly? Let's see. Here just a careless mistake. Y equals -3, but you wrote down +3, you substitute wrongly. Just a careless mistake. Okay, but your method is perfectly fine.
Okay.
This one, yeah, just error carry forward.
Oh, yeah.
This one. What is this? Treat lambda as just a constant and solve. Okay, I'll just go through this. Okay, let me read the question again. Kind of forgot. It's been 2 weeks. For a given curve, d2y by dx squared equals to lambda x minus 18, where lambda is a constant. The curve passes through the origin, good, and the gradient of the tangent to the curve 1,16 is 9. Okay, so dy dx equals 9 when it's at this point. Find the value of lambda. Okay, so you wrote down the second derivative, you integrate this, you get lambda x squared over 2, correct? 18 becomes 18x, and then you have a plus c. Good. What else? You have dy dx equal 9 when it passes through 1,16. So it's equal to 9.
Equal 1. Wait, does that make sense?
Sorry? Yeah, correct. You just have to substitute the x with 1.
Then find c. Then okay, wait. Okay, yeah. Wait, find c. And
Okay, maybe I move the screen up a bit.
27.
No, part 1 need to find value of lambda first.
Oh yeah. What am I doing? Oh, then this doesn't help. Oh yeah, then this doesn't help. Then how?
Maybe we can call this equation 1. How many unknowns do you see?
I see 2.
2. So how many equations do you need to solve 2 unknowns?
2.
2 equations, right? You only have 1. So that's when you need to find another equation. You already went from d2y to dy.
Find y equal to
just one more time.
integrate.
Good.
Then x3 divided by 6
Correct.
minus 9x plus cx plus k. Yeah, won't it be like plus k because you have
Yeah, correct. You have to. Usually I go for D because after C is D.
yeah, okay, sorry.
No, K also okay, but just in case, I think it's better to go in alphabetical order. You may end up integrating a lot more, then you better go in a certain order. If not, you
Yeah,
may get
that makes
confused.
sense.
Right?
Well, now you got
What now?
3 unknown.
Ah,
Oh no. I was gonna say sub y equals 0, x equals 0, but then you get d. Or then you have d already. Or then you sub d back, then you have 2 equations with c and then the lambda.
huh? Wait, sorry. After you solve for D, what do you do?
Then you have like the second equation to solve
But
for.
that still got X, still got Y.
Oh.
Then
Okay,
how?
now
There's 3 variables. You got Y, you got lambda, you got X, correct? But you still have X and Y. So 4 variables. Oh no, 4 unknowns. Then how?
Or sub x equals 0. Sub x and y equals 0. No.
Correct. Any other things you can sub? The X equals 0, Y equals 0?
E dy dx equal 9 and then sub x equal 1 and y.
We did that already. That's how we got equation 1. You sub into dy dx. Can we recycle any information? Okay, let's just do it first. Let me write this down. Y equals to blah 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 equals to lambda x cubed over 6 minus 9x squared plus cx plus d. Let's write down what we know. Passes through 0, 0, passes through 1, 16, gradient
x 9
equals 9. Okay, so we use the information over here, I'll call it star. And then, no, we haven't used it, sorry. We use the information over here, I'll call this star, to help us to solve for, actually we didn't solve for anything. Obtain equation
D
1.
0.
Okay, then you use double star.
D 0.
Correct, yes. You get 0 equals to 0 minus 9 times 0 plus c times 0. Even though we don't know c, we can get rid of it because you times 0 plus d. As a result, d equals 0. So a smart way to proceed is to replace the d first. So that means that y will be equal to this guy.
Yeah.
Replace the d with 0. Okay.
Yeah,
then how?
Yeah, then how?
You got equation 1. Let's just write down the equation 1 first. Usually, you see one piece of information, you see a second piece of information, you think it's you can only use it for one equation, right? But the hint for you is this you can use
sub
one
x
more.
equals to 1 y wait sub x equal 1 y equals 16 into this one.
Yes. Okay, you got it already. Yeah, that's all. Okay, just recycle. This one you can also sub in. So there's a third star, a third piece of information. So this means that, let me increase the font size first. I can sub, what is it, 1, 16. Let's just solve. From there, let's just simplify the equation. So 16 equals to lambda times 1
by
cubed 6 minus 9 times 1
plus c.
Plus c. Okay, I don't like fractions, so I'll multiply by 6. 60 plus 36, 96 equals lambda minus 9 times 6, 54 plus c. Equation 2. You got equation 1, you got equation 2. I'm sure you know how to
already. Yeah.
Okay, then you solve on your own. Can?
Okay.
exercise. Do it on your own. Then that's it. Then what's the question asking? Find the value of lambda. Okay, good. Actually, I cannot proceed to part 2 and part 3 without solving. Do you need me to go through? You think you can solve?
Wait. Find equation of curve.
Means solve for y.
Means solve for y.
You have the equation right here.
Oh,
If you
then
know
just
lambda,
sub
you know.
in lambda. Yeah, then you. Oh,
Exactly.
then that's given. Okay.
Yeah,
then,
yeah.
Well, when was find the turning points of the curve?
Also known as stationary points. SP.
dy dx equals 0.
dy dx is over here.
Then
know
you have
lambda, you know.
lambda, you have c.
Then you equal to 0. What kind of equation is it?
What kind of equation is it?
After you equate to 0.
Linear, like quadratic.
Linear?
No,
Power
quadratic,
2. Quadratic.
quadratic.
Then from there, if you solve for x, how many answers will you get? Quadratic equals 0.
You get 2 answers.
So how many stationary points will you have? That's why they use plural over here. S. Plural. 2 points. I think you know how to solve lah. I don't need to go through.
If they want turning points, do I have to say like the nature of the turning point? Okay,
If they never ask, then don't need.
Can just like okay, yeah.
These are coordinates. But for practice, you can prove that it is figure out the nature of maximum, minimum, or inflection point. You can do second derivative test or draw the table for first derivative test. This one do until you're bored already, right? I'll leave it as an exercise for you. Okay.
That's differentiate then S. What's S?
Solve.
I know equate. Oh yeah, equate equals 0. Then solve. Then deal.
I guess it's quite obvious. After you equate to 0, you don't just stare at the equation. You solve the equation straight away.
Okay.
So this one a bit obvious. I'll just write it down. Solve. Then TA for table. Okay.
Okay.
Again, let's move on. Let's go to the next homework you submitted. 18.2 is it? Let me find it first. Wow. Oh.
I think 18.2 is it definite integral? Then like I think I'm a bit how to say.
Not familiar with the notation.
Oh, okay. Yeah.
Sorry, what were you trying to say?
No, I'm very confused when it comes to the I don't know how to say. It's like later the questions, then you'll see like
Okay, can. So key thing to take note is that it's supposed to be square bracket over here. Then x equals, then you sub in. So at some point you somehow change it back into a round bracket, which is not correct. Use square brackets all the time. Okay, it's international notation. If not, you confuse your prof in the future.
Okay.
Right. Okay, good. Change back to square bracket somehow.
And change back to round bracket.
Then round bracket and square bracket. Don't be so inconsistent. After you substitute the x equals 0, x equals -1, like the upper and lower limits, then you can use round brackets. Okay. Can yeah.
Yeah.
Then this one okay, this one is very good. You did it correctly. Okay, nothing to say. Move on. Yeah, you did it correctly. Some students they see 0 and -1, they'll end up substituting -1 to the left, 0 on the right, which is wrong. Upper to the left, lower to the right. Okay, always. Upper to the left, lower to the right, minus in between.
But 0 is the higher value. Like I mean, I know that's not how you're supposed to think, but
the on top goes to the left. The below goes to the right. Okay, always.
All right.
Don't look at the value. It's a position. On top goes to the left, below goes to the right. Okay. Continue. What else? Here, I just suggested that you could integrate it a different way. Because this is linear to the power of 2, you can just raise the 2 to the power of 3, like +1. Add 1 to get the new power, 3, then divide by 3, the new power. Chain rule?
Wait, no, not chain rule. I mean,
for the red color part, it's just the opposite of power rule. Add 1, get the new power, divide by the new power. For this one, I purposely add in an extra blue color to remind
as
you
in
that you need
times
to use
the
chain.
coefficient of 1. I mean divide by.
Divide. Yeah.
Yeah. Okay.
Right.
Wait,
if it's
why
a
do I
7, then choose.
expand? I expand.
You expanded it, then integrate term by term. Also perfectly fine. Same answer.
Okay.
Okay. And then you equate to something and you solve for k. All right. Yeah. Then whenever you have power 3, there will be 3 solutions, but 2 of them will be
The
complex
other two
numbers.
imaginary.
Imaginary I equals square root -1 involved. So don't worry about it. This guy, what happened? I think there was just some careless mistake with the substitution because the integral was fine. You sub in, yeah, you type in a calculator wrongly. This step is perfectly fine. It's just the next line. It's supposed to be -1/6. You type in a calculator again.
Okay.
Check on your own. This one is fine. What happened over here? Square bracket. Okay. Then, area under curve interpretation, 11 part 1. Okay, this part. Draw a curve, step 1. Step 2, if a sharp point is detected, a non-unique tangent, you have to split the limits. Otherwise, you have to integrate as per usual. Okay, this one is relevant to the topic I'm gonna introduce today because I realized I didn't explain it in enough details. But the definite integral is really just finding the area under a curve. Okay. So I'm gonna skip this first. Sorry, you might not have enough prerequisite knowledge to do this yet. 18.2. This was from which exercise? Let me see. MF360. Okay, let me bring up the question. Okay, let me just show you without explanation how I would do this question. For 11 part 2, what they are asking for is 11 part 1, they ask for integral of x0 to x squared from 0 to 2. Then for question 11 part 2, okay, I need more space. Maybe I'll add a page here. Okay, no, I will add it to this new worksheet. This is exercise 18 point, let me check first. 18.2, question 11. Part 1 asks for integral of x from 0 to 2 dx, which is x squared over 2 sub in upper and lower limit, x equals 0. Then we end up with 2 squared over 2 minus 0 squared over 2, which becomes 2 minus 0, which is equals to 2. Let me try and make it look nicer. Like, okay. Sorry, give me a second. I need to close and open. Okay. Where was I? This one. Yeah, then for part 2, right, what they were asking you to do is hence you want to find integral of negative, let me find the question again. -2 to +2 of modulus x dx. Okay, so what you need to understand is that when you try to find a definite integral, it's actually the area under a curve from y equals to, in this case, x, the middle guy, from x equals to 0 to x equals to 2. The 0 being this lower limit and the 2 being that upper limit. So what does it really mean in terms of a graph? It looks something like this. Here is the graph of y equals to x. There is x equals to 0. There is x equals to 2. Then we want to find the area under the curve. So if you can imagine, you are standing on top over here. Then you drop down a bunch of, I don't know, maybe pinballs or something. Then you end up with this region here. Okay, I'll shade it in yellow. This is the regions, this is the area that you want to find. And the integral, definite integral, gives you the answer. Okay? And until the x-axis. So over here, integral of modulus x, what are they really asking you to do? First step, draw modulus x. Here is y equals modulus x. Do you remember the topic of modulus?
I thought cancel from CD plus.
Huh?
Wait, is it not? I mean, all positive, like if it's not
correct. Yes. So in this case, right, y equal x looks like this, but modulus x just means the part that's below x-axis, you reflect it on top. So you end up with a triangle shape like this. Okay? Like the bottom part goes on top. Then you want -2 to +2. Sorry? Yes, 4? Exactly. Yes, by symmetry.
It's just
That's
4.
You just need to know that here is x equals -2. There is x equals to 2. They're asking for the area under the curve. So it must be this left half over here plus that right half over there. And you already know the answer for this right half. This is just the answer from part 1.
What's the
by
difference?
Symmetry, this is by symmetry, this area must be equal.
What's the difference if it's not modulus? Isn't it the same if it's like not modulus?
Isn't it the same if it's not modulus? What if it is not modulus? Wait, let me just write down the answer first. 2 + 2 equals to 4. Part 3, bonus question. What if you instead have -2 to +2 of just a x? In this case, I haven't introduced the topic yet. But areas that are under the x-axis are negative. Areas that are above the x-axis are positive. So let's take a look. This is y equal to x.
So 0.
Here is, yes. This is x equal to -2. This is x equals to 2. So there's a positive area 2, positive 2, and there is -2. -2 + 2 will give you a 0. Okay. I'll talk more about it later. Can?
Okay.
Okay. Good. Go back. Over here, nothing much. Okay. Here's the part that is not done correctly. Let's take a look. Question 14. So question 14 gave you a few things. Integral from 0 to 3 of fx dx equals to integral 3 to 8 of fx equals to 12. Here, what is so special about it is that the f of x is not given. F of x given as a generic function. So you don't actually know what exactly is the f of x. Is it a sine of x? Is it cosine of x? E power x or x squared plus 3? That kind of thing. No specific details, just a generic function. Okay. So this is when you need to know the properties of the limits. So let's take a look at this one. If you know this equals to 12, what they ask you to do next is find the value of each of the following. First part, integral from 0 to 8. So good, you managed to do it. 0 to 8 means you can split it up from 0 to 3 followed by 3 to 8. Okay, 0 to 3 followed by 3 to 8. You can interpret this in terms of an area. So let's see. If f of x looks something like this, a curve y equal f of x. Pretend it looks like that. Then here would be x equals, oh, sorry, I need to make the curve a bit longer. Here will be x equals to 0. Here will be x equals to 3. There will be x equals to 8. So when they ask you for integral from 0 to 8, what they're really asking you to do is to find the area under the curve, like this. Okay, the total area under the curve. But what you realize is, you can split it up into the left area here Okay, let me change the color. Wow, lag. So much lag. Okay, so they're asking you for the yellow color area here from 0 to 8. Then what you realize is you can split it up into a left half, which is the area from x equal to 0 to x equal to 3, which I shaded in blue color, if you can see. And the right half, the purple part, which is the area from where to where for the purple part. Can you answer?
3 to 8.
3 to 8, very good. So that's why you're able to split it up like this. From 0 go towards 3, then from 3 go towards 8. But you know each of these pieces, they are both equal to 12. So you can replace with 12 plus 12, which is 24. Okay, good. How about part 2? Part 2 here, what you need to know is that when you integrate some sum, right, you can split up the integral into the integral of each term. So that means that actually you are doing it halfway already. You can do the following. Integral from 3 to 8 of 1 plus 2 f of x dx, square bracket. You can split it up. Integral 3 to 8 of the first term plus integral 3 to 8 of the second term. Is this clear so far? It's just like differentiation. You can, when in differentiation, you can differentiate term by term. In integration, you can integrate term by term. So let's take a look at the first term. Integrate 1. What do you get? X. What else do you need? Square bracket. Definite integral. Lower limit x equal to 3. Upper limit x equal to 8. How about this second guy? When you have a factor 2 in the f of x, multiplied by the f of x. Factor it out. So that means you get 2 times of the integral from 3 to 8 of fx dx. So this first guy, let's just calculate it. Sub in the upper 8, sub in the lower limit 3, you get 8 minus 3. Plus 2 times of something. What is the integral from 3 to 8 of fx dx?
12.
12, very good. So we can replace with a 12. So 8 minus 3 times, plus 2 times 12, 24. 8 minus 3, 5, then you get 29. Is that okay? Very good. How about the last part? You want to try? Let me copy the question. Integral 3 to 8 of 2 times fx dx. And then the plus 1 is outside the integral.
One outside. Bring out the 2. So it's just the same as the previous question.
Do you need to integrate the 1?
No.
The integral distribute into the 1?
No.
Don't need. Why? Because plus
Outside.
1 is outside of the dx. See, the integral and dx, they are sort of like the head and the tail of the integral. So the plus 1 is clearly outside of the integral. So you don't go and integrate the 1. Okay, so what is integral from 3 to 8?
25.
Okay, it's 12 and then plus 1, 24 plus 1, 25. Okay, next part, let's see. Find also the value of the constant m for which, this is extra.
What is
Extra
this?
Integral 3 to 8 of f of x minus away mx square bracket. Let me write it neatly. Dx equals to 0. So just follow the rules. You see plus or minus, what do you do?
Separate the terms.
So you get the integral of the first guy, dx, plus integral of the second guy, negative mx, 3 to 8 dx. Okay? Can? Equals 0. Just make sure the 3 and 8 must repeat. Then how to continue?
Okay, so the first term is 12.
Good.
Plus.
Let me get to
Wait, actually, you can minus m, like minus bring out m, then Then wait, is it? Yes.
Yes, exactly. So you end up with negative m factored out. So you're just left with integral 3 to 8 of x dx equals to 0. So 12 minus m multiplied by, what's the integral of x?
Minus 3, 5.
Huh? What's the integral of
Wait.
x?
Wait.
X squared over 2
uh,
first. Must do carefully. Then x equals
5
3, x equals
minus
8 equals 0. Then next line, 12 minus m times 8 square over 2 minus 3 square over 2 equals 0.
what's
And
64
from there,
minus 9? 55 over 2.
64 over 2 minus 9 over 2 is 55 over 2 here. There's a negative m in front. There's a 12 equals 0. From there, you can solve for m. So 55 over 2m equals to 12. M equals to 2 over 55 times 12. 24 over 55. Okay, good. Can. So let's see. That should be, oh wait, this is 18.2. What else? Did I give you more homework? 18.3. Let's see, 18.3. Wow. 18.3, where is it? Over here. You did question 9. Was it okay? Here, a mistake. Can you see the mistake? -1 coefficient in front of x. Then you have to use your chain rule, but for integration. So it's the opposite of times, which is divide. Divide by a -1.
Wait. Okay.
Oh, hold on a second. This is integral of sine. Then you should get negative cosine. Oh, negative and negative cancels off, become positive. Right?
Okay,
Oh,
now I'm confused. Wait.
Sorry, let me edit this.
No.
You're correct. You are correct. I didn't see that. My mistake. Can you help me to correct this?
Wait, I'm confused. Wait, I sort of forget the trigo
Okay.
for integral. Integral for trigo. When there's the sign, then if like inside there's like, okay, I know if it's 2x, then you just like is half, but then like if it's like 3x or something else like that, then how do you?
Okay, let's recap with the derivative first. Differentiate
Okay.
sine, you get cosine. Differentiate cosine, you get negative sine. Right? So from there, you can work backwards. So let's see. If you integrate sine of, let's say, 7x ex, what is this equal to?
Where are you? Wait.
Negative
Okay,
sine will get back cosine.
Wait. Negative negative cosine x. Wait, no,
Yep.
but
Negative cosine. Just remember negative cosine first. Then whenever you have anything inside, you just copy and
7x.
paste. Right?
Then divide by the coefficient.
Yes.
Okay.
How do you check that you integrate correctly?
Or differentiate this.
Yeah. What's missing? What else is missing?
What else is missing? Plus C.
Yes, plus C.
Okay.
Can. So over here, when you integrate a sine, there's actually it just becomes a negative cosine. But there's a -1 over here, so you have to divide by -1.
Then okay.
And then you have a factor of 2 that you factored out. Okay, so negative cancels away. Maybe I show a bit more working lah. Over here, integral of 2 sine pi minus x dx will become 2 times of integral of that guy, which is 2 times of negative cosine pi minus x. But you have to divide by the coefficient here. So -1 plus c. Plus c. Okay. Negative cancel away. That's how you get your answer. 2 cos pi minus x. Okay, so sorry, I was wrong. Wow, this one. Bad. This is correct. I didn't see the negative. Okay, this one should be square bracket. Okay. Then as a result, you get this expression, which is okay. Cosine 0 is 1. So 2 times 1 minus away 2 times cosine pi minus pi over 2 is cosine pi over 2. Cosine pi over 2 is 0. So it's just 2. Okay, your answer was correct. I was wrong. Sorry. This part cancel off. But the main point I wanted to bring up is that you can actually factor out the 2 here. You see, when there's a 2 here, you can actually factor out from the square bracket. Before you sub in. Because it's equivalent, right? You can also rewrite it as 2 times of square bracket cosine pi minus x. Then you sub in the lower pi over 2 and the upper pi. Okay. Good. What else? Let's see. Question part C. This one they ask they need an exact value. So here you don't want to use a calculator yet.
Okay.
This one you have to calculate the exact value, which is let's see, 2 pi over 6 minus pi over 6. Then that will be just pi over 6, sine pi over 6, sine 30 degrees. That's 1/2. So 6 times half, you get a 3 over pi, and so on and so forth. I'll leave you to try on your own. Is that okay?
Okay.
Can. And Trigo, that's all you did for this one. Did I ask for anything else? I can't remember. Question 1, 3, 4, do all parts. You started with a question 9. Huh. Wait, did I? No. I'm looking at the wrong homework. Oh, I only asked for question 9. Okay, can. Then how about part D? Part D was done as well. Okay, can. This is fine. Okay, homework question done. Can? Okay. Okay, wait, let me send you the file first in case I forget. Where is it? Here. Okay, I need to update the date. Give me a second. Okay, then back. Hey, did I send the wrong file? Let me double check. 18. Oh, no, not this one. 18.2, 18.3. How about 18.1? Right. Sorry. Let me send the 18.1. Okay. Then back to what I was planning to do today. Okay, let me share screen first. Okay, let's take a look at this question. 6 questions. I'm gonna go through all of them one by one. Ken,
Okay.
I think I sent you the file already. Or maybe you can try the question first before I review.
Okay.
Okay, given integral from 3 to 5 of fx dx equals to 7. Part 1, I want you to find integral from 5 to 3 of 8 times fx dx.
Oh no, this is the type of question where I suck.
Let me teach you. Let
Like
me
like you know what I mean, right? Like this sort of thing. Like you know like the
limits of the definite integral where the fx is unknown.
yeah. Then wait no, but I know the first one. Wait. I know. Wait, trust me.
Try.
The first one I know, but then the rest is like I know that if it's flipped around, I know it's negative.
Then solve it.
So it's
8 times.
8 times -7. The
Exactly.
part 1.
That's it.
Okay,
Yeah.
I just know that.
Okay, let's just write it down. 5 to 3 of 8 fx dx. This will become 8 times of integral from 5 to 3 fx dx, which is equals 8 times. This one you can introduce a -1, multiply by, flip it around, 3 to 5 fx dx, which will become -8 times 7, which is -56. How about part 2? Let's try. Try first. What are the few generic rules you need to know? First thing, integral from a to b of fx dx is equal to -1 times of b to a if you swap the limits. Another thing, integral from a to z of fx dx is equals to integral from a to something in between, let's say b fx dx plus integral from b to z fx dx. Okay, as long as this one and this one is the same. How can you interpret this? I draw a nice little picture on top over here. Oh, I use z. I use c instead of z, but it means the same thing. So let's say that if you have a curve like this, y equal f of x, left half is integral from a to b. Right half is integral from b to c. And they are really representing the area under the curve. So if you want the total area, it's equivalent to adding up the two areas on the left and on the right. In other words, total area equals to a plus b. But how do you find total area? It's just the area from x equals a to x equals to c. So this is something new. You must know. I am teaching you now. Total area from a to c is written as integral of f of x from a to c dx. Lower limit is the smaller x. Upper limit is the bigger x. Here and there. Okay? Right. This is the interpretation of the definite integral. It is total area under the curve. But you can always split it up into the area of A plus the area of B, which means that it must be going from little a to little b, from A to B,
Oh my god. Okay.
and then from little b to little c, here to there. Does it make sense?
This. I hate the what is it called? Limits? Is it limits?
Yeah, the limits of the definite integral, upper and lower limits.
I hate limits on definite integral.
Yeah, you have to get used to it. Very simple. And after a while, you'll get used to it. Okay, it's just reading the x-axis. A go to B, then B go to C. A go to B, then B go to C. Okay, just keep this picture in mind when you're
Okay.
trying to integrate. Okay, let me just take a screenshot of this. Then then you can have a reference while solving this question.
When there's a 7. 7. Oh wait. There's a 7 and
How?
Oh. Okay, wait.
Let's copy down the question first. That should be our first step.
Okay, so this part you want to separate the term. Wait. Yeah, you want to separate the term. So like this, then
Good.
wait. Okay, yeah.
All right. Let me write down. Sorry, pause a while. Okay, can carry on. One more rule I forgot to mention is let's say a times f of x plus b times g of x dx. Let's say you integrate from, I don't know, a, b, c to d. You can split it up into integral from c to d of a times f of x, but the a can factor out. So it's a then fx dx plus b integral, still the same lower and upper limits, but now it's g of x dx.
Okay.
Okay, it's just like differentiation. Differentiation, you differentiate this format. You can differentiate each term, but you need to factor out the coefficient. Okay. So anyways, back to this. Let me copy down what we know so far. Integral from 3 to 5 equals to 7. And integral from 5 to 3 is negative 56. Sorry, of 8 times f of x is negative 56. Okay, continue.
Okay, so I know the middle one is solvable.
Solve it now.
Wait.
You can also factor out the 4 from the square bracket.
Oh
Have you
yeah,
tried
yeah.
it?
Yep. 7 minus 5 is 2, so that's 8. So middle term is just 8.
Yep.
Okay. And it's just 8. So 7 3 fx dx minus this is plus 8.
Pause a while. Let me copy down the rules for you so you can have a reference. Copy, paste, copy, paste. Carry on.
Okay, so okay, so I can make okay, so I can make this minus wait no. Okay, wait, never mind. Wait. Okay, I do
And
this.
that can work.
Okay, then I do this.
Leave it alone. Okay. Dx.
Then I use it. Wait.
It's a
Okay,
plus
then
sign.
I factor out the minus 1.
Very good. Yes.
then like plus. Then I can use this one.
Yes.
So
because addition, you can swap left plus right, right plus left. So it's equivalent to integrate from 5 to 7, then from 7 to 3, which combines to become
wait, I'm confused.
the middle number can always be bigger than the two other numbers. Okay. Wait, let's write down what you have done so far. Equals to -1 times integral 7 to, okay, bracket 7 to 3 fx dx plus integral from 5 to 7 of the same integrand fx and end off with a dx plus 8. So over here, what I'm saying is that left plus right, you can always write it as right plus left. Swap it around. So let's see what happens. This guy goes to the left, plus the left guy goes to the right, like this. Close the bracket, plus 8. Can you see that it matches up with this pattern?
Yeah, then yeah.
Then combine. What do you get? -1 multiplied by
-7.
Yeah, correct. Yes. One more step. It's actually 5 to 3 fx dx, close bracket, plus 8, -1 times this guy. But we only have 3 to 5, it's +7. So that's when you need to swap it around. So you integrate 3 to 5, but with an extra minus sign outside. Fx dx plus 8, which is equal to -1 multiplied by -7. Yes, plus 8. Oops. -1 times -7 becomes +7 plus 8, which is 15. Okay? Can?
Yeah.
Can. Yeah, there's a few steps that are skipped. You can fill in the blank on your own. You already wrote it on the screen. So the main point here is that when you integrate like this, even though the middle number is bigger than 3 to 5, right, it's perfectly fine. As long as you follow this formula, you will always be able to combine them. One more condition you must take note of when you want to combine is that the integrand must always be the same in all three of these. Okay, integrand must be the same before you can combine. Let's just do a quick experiment to check that this rule works out. Integrate from, let's say the f of x is, this works for any f of x. This rule works for any f of x. This is equivalent to integral from 5 to 3 of fx dx. Let's check that this works for f of x for two different examples of f of x. Example, f of x equals to, I don't know, e power -2x. Okay, let's try that. So first one, integrate f of x dx in general, the indefinite integral. What will you get? What is it? What's the answer?
You will get ln.
Ln.
No, that's one. No, that's this one. Alright. Wait, I'm confused. Wait, let me think.
Differentiate something, get e power.
Oh yeah, differentiate this.
Correct. Yes.
Yeah, but then, so
You can change the power over here to -2x. What do you get if you differentiate? Correct. But it's off by a factor of.
wait, what again?
So differentiate will give you the answer on the right side. You integrate to work by words. Then you work by words to integrate. But it's off by, it looks very similar already. Right? It's just off.
Wait.
Yes. That's it. Correct. -2. Okay.
I'm gonna differentiate to check.
Differentiate to check. Go. Do it.
Okay.
Essentially a negative half coefficient.
Yeah, because you times -2, so cancel. Okay.
So in general, whenever you have the coefficient of x, you just divide. Okay. Just like sine, just like cosine, tangent, e power, ln, something, you just divide. Okay, so anyways, e power -2x divided by -2. I'll just, okay, plus c. Then now, because we're doing definite integral, you can just essentially throw away the plus c. Let's see what happens. Integrate from 5 to 7 of this fx dx, where fx happens to be e power -2x. Well, that just means we sub in upper and lower limit. No? Sub in with 7, sub in with 5. What is this equal to? E power -2 times 7 over -2 minus e power -2 times 5 over -2. Okay, I'll leave it. I won't try and simplify. I'll just leave it alone. How about the integral from 7 to 3 fx dx, where f of x happens to be e power -2x. We just have to copy and paste this, but replace the numbers with the x with what is it? 3 and 5.
7. I mean,
sorry, 3 and 7. Correct. Yes, I misspoke. Okay, then the final one, 3 to what is it? 5 to 3. 5 to 3. You just have to copy that answer, but replace the upper limit with a 3, lower limit with a 5. Okay, can. So what's a funnier notation we can come up with? Integral of little f. Do you recall? Fx, you differentiate. D for differentiate, you get f prime of x. Then of course the opposite direction, integrate. Is there another notation we have for this? Differentiate and integrate?
notation.
The very first lesson.
Capital F.
Capital F. Oh, my arrow direction wrong. Like this. It's a capital F of x. So what's a fancier way to write this? It will be capital F of 7 minus capital F of 5, where this equals to f of x. Okay, f of x is the integral, which is this function here. But then I'm replacing the x with a 7, so f bracket 7. I'm replacing the x with a 5, so f bracket 5. Okay. Likewise for this guy, what would it be? Capital F of 3, because I substitute the upper limit, minus capital F of, what is it? What's the lower limit?
7.
7, good. Last one, tell me. F of?
3 minus f of 5.
Okay, good. So now can you see how if you add f of 7 minus f of 5 plus f of 3 minus f of 7, the f of 7 will just cancel away. You're left with f of 3 minus f of 5, which is exactly what we have here. Can you see that?
Mm-hmm.
So this is equation 1, this is equation 2, this is just 1 plus 2. Okay, that's why you can add them together. In general, this is just basically what's going on when you have these two limits being the same, and the integrand is the same, f of x. Do you need another example to highlight this idea?
I think it's okay.
Only, yeah? Okay, then I can move on. Okay, more difficult questions. Let's go. Okay, that's the one. This is question 1. Question 1.
Okay.
Oh, I wanted to cover 6 questions. Okay, I must go faster already. So let's take a look at question 2. This one quite basic. Just the integral. Just the integral. Let's take a look at this. You wanna try?
Okay.
Okay, go.
Bring out the 5.
Good.
Then
Good.
Okay. Then okay, +1.
Open square bracket. Open square bracket.
Open square bracket.
Square.
Oh, open square bracket. And
Add 1, get the new power, which is a positive half, divide by the new power. And then divide further by the coefficient of x. Good. Close the square bracket.
then
-5.
oh. Okay. Oh shoot. Okay. Okay. Looks very not nice.
Don't worry, it's correct.
Negative. Then calculate.
Yeah. Okay. Then we can move on already. You got it. It's correct. I send you a screenshot of your working. The rest is just simplifying. Okay. Can?
Okay.
Can? Okay. Very good. I can move on. This is a recap. Okay, move on. Question 3. Let's go. So, question 3, we have this fella here. What do you do this time? When there's a power 2. Can you just add 1, get a new power, then divide by new power?
Add 1, get a new power, divide by new power.
Can you do that? The power
No.
bracket power 2, then become +1, so power 3, then divide by 3.
No, because the x
Why cannot?
is the power is. I mean, when x is -1 cannot. I mean, when the power of x is -1, then cannot. Cause it's ln. Cause it's ln. Cause if you differentiate ln, then it's wait. Yeah, no. If you differentiate ln, then it's wait. It's not
1 over
like,
x.
I mean, yeah, it's 1 over x. You get x to the power -1. So when you have x to the power -1, then the reverse chain rule doesn't work.
Yes, correct. Okay, in general, what you're supposed to know, at least for your syllabus, is that in between the brackets must be power 1 in terms of the variable. In this case, variable is x. Variable. So it has to be linear in the variable. In this case, it is not linear. Okay. This guy is the variable. This integrand is not linear. What I mean by not linear is the ones in between the bracket. Okay. Not linear in terms of x, where x refers to the variable. Okay, so how to integrate? Carry on. If you cannot just +1 straight away, what do you need to do when you have power 2?
Ln. Wait, when I have power 2.
Open brackets, blah blah blah, close bracket, power 2.
Oh.
A minus b bracket square. Got 2 terms inside, binomial.
Can you
A minus b bracket square. What do you do?
A minus b bracket square, a square minus b square. Wait.
Minus 2ab plus b square.
Yeah, I mean
Right,
that's true.
Then how do we continue from here? What is your A? What's your B?
4 minus
Right, then carry on.
4, and then B is 3x.
3 over x.
You or can't you just wait, why can't you just like that?
And where's my square?
Oh yeah, oh,
Where's my square?
oh yeah. Oh,
Yeah, the square is applied to the whole expression. You cannot distribute the integral into the square. No such thing. Wow, that would be a very interesting function. The integral of fx.
man, why can't I just expand?
Just expand. Yes, exactly. That's what I'm hinting you to do. Yes,
Oh,
please
yeah.
just expand. Wow, if we had such a function, you bring inside the square. Integral bring inside the brackets. And then you square outside. What kind of function is that? Find an example. Wow, this seems like an ordinary differential equations question. Very challenging.
This one is 16. Okay, then the x power minus 1 is just 24 ln x.
Good.
Wait. Okay, yeah. Then this one is just wait. Okay,
Bring up first x power
x-
negative 2.
X power negative 2 plus 1 x power negative 1. So and then just divide by wait. X
Just do it step by step.
okay,
Leave it as power negative 1. Okay. Most important thing is to get the right answer. Because the
negative 1 divided by minus 1.
Good. Correct. That's it. Plus C.
Huh?
No. Need to sub in 0. The 2 and 1. Okay, then you can simplify now. Negative and negative cancel, become positive. Then 9 times x power negative 1, the x can bring down. I recommend you to leave the working when you're writing down for exam purposes or for practice. But for now, I think it's okay. Yeah.
Wait, I'm confused. Is it not 9 over x?
Yes, it's 9 over x, correct. I think it's a positive sign.
Oh, it's positive sign. Wait. Let me try again. Okay, wait. 9x minus 2, right? Then you add 1 power. Then become negative 1. Then you divide by minus 1.
Hey. Oh, sorry. Let me see again. I might be wrong. Oh yes, you're correct. It should be minus sign. Yeah, you're right.
I wrote the wrong
Negative.
sign. Is it just now I wrote plus, then I wrote minus. I think that's what I put.
I'm not sure what happened.
No, I think
but
that's
should be negative 9 over x. Should be negative 9 over x.
Yeah, I wrote minus. I just did the undo thing. Yeah, okay. That's my bad. That's my bad.
Okay. So negative 9 over x. But we are actually doing a definite integral, right? With the limit
then no minus c.
1 to 2. So here's
no
what
plus.
you can do. You can just go to your integral sign, you put a 1, you put a 2, and everywhere you put a square bracket. Oh, sorry, haven't integrated yet. So now every integral you have, you just put on a 1 here, 2 here, 1 here, 2 here, 1 here, 2 here. Yeah. Every integral must have that 1 and 2. After you split.
Okay.
Okay, and then you sub in. I'll leave you to sub in on your own. Okay. And then I realized, help me to change the question. I cannot have 1 because what happens if you substitute 1 into ln? Oh, wait, sorry, still can. Nothing wrong. No. I got confused. I take that back. No, it's only a problem if x equal to 0. Ln 0, then undefined. Okay, safe. Nothing.
Okay.
Okay, question 3 done. Let me take a screenshot. Then I'll let you copy on your own. Okay, give me a second to shrink this. Oh no. Let me adjust this. Okay, can. Moving on. Question 3 done. Wow, quite late already. I must go faster. Go. Question 3 is done. 4, 5, and 6. Let's take a look. How to solve? What time is it? It's 9:37, right? Okay, let's take a look at this question. I have to go through already. So for part 1, differentiate sine of blah 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 and show that it will be equal to that right hand side. So let's just do that. Differentiate sine of square root e power x plus 1 all divided by 2. How? What rule do you need?
I can't wait. Oh.
I help you to
What rule do I need?
Okay. Or just tell me how to differentiate this. Who's the outermost function?
Sine.
Sine. So differentiate sine you get?
Yeah.
Cosine, right? So straight away, cosine. What's
Sine.
inside the bracket?
Square root.
Everything, right? The whole thing. Copy and paste.
Then
Okay.
the chain rule. I mean,
Times, yes, chain rule,
times.
exactly.
Yeah.
Derivative of the
Inside.
inside. Oops. Let me just copy this. Good. Okay, good. Then you carry on. Cosine, leave it alone. Multiply by derivative of this guy. How to differentiate this one?
Bring out half.
First, then you're left
Then-
with derivative of square root e power x plus 1. So next line, differentiate square root e power x plus 1. How?
Negative from power half become power negative half.
Yes. In this case, just
1 over ex. I mean,
bring down the all power of 1.
okay.
Multiply the base, then minus 1 to get a minus half. Anything else? Yes, chain rule again. Okay, so times the derivative of e power x plus 1, which is just e power x. Okay, so we can simplify everything now. This guy becomes times e power x. The one differentiate you get 0, so I don't bother writing. Okay, plus 0. E power x plus 0. So it's just simplified to e power x without the brackets. Okay, now we simplify. So cosine of all that leave alone. Half times half becomes 1/4. So I'll put a over 4 at the bottom. Then there's a power negative half, so I can bring down. So it becomes e power x plus 1 to the power of positive half after I bring down. Don't need to write plus sign. Then if I want to make it cleaner, I can rewrite the power half as a square root. E power x goes to the side. Can?
Mhm.
Okay, good. Let's just make it look nicer. So now I have this guy equals to cosine something times e power x. This guy power half becomes a square root. Okay, let's see if it's the same as the question. Yes, it is the same. E power x multiplied by the cosine of that thing, all divided by 4 over square root. 4 times square root e power x plus 1. But part 2 is more interesting. Okay, part 2, what does it say? Hence, we want to find the exact value of this fellow over here. Can we do that?
How?
How? Why do you think it's a hence question?
Hence, using because it's the same thing. Okay. Yes. Okay. You use this.
Let me
Yeah.
copy down the question first. So therefore, for part 2, this guy must be equal to what?
Equal to square bracket. Square bracket sign. Bracket open. Square root ex plus 1 over 2. And then bracket
So
close.
square bracket.
And then x equals to log 48. X equals. Yeah. Okay.
Yeah. Okay, 48 on top and 3 below. Next.
Then.
Exact value.
Cannot use calculator.
Yes.
Huh? Wait, then how?
Sub in and
Oh.
you'll see how.
Okay,
You
sine.
just sub in. Sine
Okay.
square root e to the power of
log 48. Oh, because you bring down the 48. Because this
yes,
and this. Okay.
over 2.
Over
And
2,
then the other guy, copy and paste. I just replace the 48 with a 3.
3.
Okay.
Then you bring down the 3. Because this.
E to the ln of x, just help me to remember this, is the same as x, which is also the same as ln of e power x. Okay? E power ln x, ln of ex. They'll all be equal to the x. In this case, the x is 48, the x is 3. So let's just simplify this down. You end up with sine of square root 48 plus 1, then square root the whole thing, divided by 2, minus away sine of e and ln cancel away. You're left with just a 3 plus 1, take a square root over 2. So calculate this. 48 plus 1 is 49. So square root 49 is 7, right? Over 2. Minus away, sine of 3 plus 1 is 4. So square root 4 over 2. Square root 4 is 2. So you are just left with 2 over 2. Can simplify a bit more. 1 over 1. Okay? So that's the final answer. Sine 7 over 2 minus sine 1. That's it. Don't simplify. Can? Okay, good. You can find exact value like this. Just don't simplify. That was one question. That was question 4. How about 5 and 6? Let's see. Wow, how much time? 9.4. Okay, I have until 10:15. Let's see. Okay, question 5. Let's see. Prove the following. Differentiate x over cosine x becomes secant x times x tangent x plus 1. And then hence solve for the value of k that satisfies the following equation. You have scary integral on the left, another scary integral on the right, equal. But then there's a k over here. Solve for k. Exact value. So let's see. Part 1. Oh, by the way, this one, if it's an exam question, the part 2, the part 1 is there to help you. Because if you cannot prove the derivative equals to that guy, secant x times whatever, you can still use the result. Okay, I think you can see by now this and this, they are the same, right? Can? Following so far?
Yeah.
Yes, okay, then I proceed to differentiate. You see x over cosine x, what rule do you want to use?
What rule do I want to use?
Fraction, all right. Fraction.
Fraction.
X over cosine x is a fraction. So how?
Quotient rule.
Quotient rule. What's a quotient rule? Repeat. Low.
High less, high D low. Draw the line square below.
Yes.
Cosine x. Sine
So let's
x.
just do the simpler one first. Square below. Or square x. Bottom
Cosine
D top
x
minus
minus
times
x
1. Okay, then minus x times
times differentiate of cosine x, which is just negative sine x.
okay, very good. Simplify. So this is just cos x plus x sine x all over cos square x. We need secant x. How?
You need secant x.
And then you
Okay.
have to multiply our x tangent x. Okay, we don't just need secant x, sorry. We need secant x multiplied by this guy, secant x multiplied by that guy.
Okay. I mean, okay. If you 1 over cosine x plus wait, do I make sense?
Okay, now it's trigo identity. Sorry, what?
1 over sine
Yes,
x
correct. Cos x
plus,
over cos square cancel becomes a 1 over cosine x. Yes.
then this one okay, sine over cosine tangent
X
x.
sine x over cos square,
Tangent
right?
x over cosine x.
Yes,
Oh,
correct. Sine over cosine gives you a
then
tangent.
x.
And the x in front, right? So this is x.
Then because the cosine x below is just secant, so then you just do this. Secant x.
Good.
Secant x. And okay, yeah.
The cosine goes up, you get secant x. And then you factor out the secant x. 1 plus x tangent x. Just to make it look nice, I will bring the plus 1 to the right. So you see trigo identities coming back to haunt you. Okay, I don't need to write down. I'll just say shown. Okay, differentiation, trigo, and everything else is coming back to haunt you. Okay, can be that scary. Okay, now let's take a look at part 2. Okay, do you think you can solve this? Can one. Very, very doable. Which one looks okay? Let's take a look at the left hand side first. Does it look familiar to you? Yes, right. The green color.
Yeah, it's the same.
Good. So after you integrate this, what do you get? Left hand side. Square bracket.
X over cosine x bracket close.
Limit is x equal
0. I mean x equal pi over 6. And on top is x equals 0.
Very good. Okay. Please drink some water. Okay. Then the right hand side, pi over k, we can't do anything. Can't do anything. But what about integral of secant square? What's integral of secant square?
Integral of the tangent.
Very good, tangent. So we're gonna write down square bracket tangent x. Close the square bracket. X equals the top one. What is it? X equals
Pi over 6.
of course, top copy top, then bottom copy bottom. So pi over 3. Okay. Easy. Easy, right? This one. Hence. Okay, moving on. So now just sub in. So we get 0 over cos 0 minus away pi over 6 over cosine pi over 6. Sorry, I'm writing the pi over 6 in slant notation to save space. And pi over k multiplied by square bracket. This one, tangent pi over 6 minus away tangent pi over 3. Okay so far? Sabine, can understand, right?
Mhm.
Yes, okay, good. Now we continue simplifying. Cosine 0 is what? Is it 0? Cosine 0 is?
Cosine 0 is 1.
So any issues here? Divide by 1? Can, right? We can divide by 1. It's only an issue if you divide by 0.
By 0.
So what's 0 over 1?
0.
I want
pi
exact
over
value of k. So pi
over
over
6
6 on the numerator remains.
30.
What's cosine pi over 6?
Cosine 30 degree.
Can continue?
Cosine 30.
I don't want you to convert to degrees. Give me exact value.
Okay. Wait, I draw a triangle.
Triangle? No, calculator trick. What's a calculator trick? Okay, I can also have triangle.
Can. Wait,
Okay, carry
2, 2, 2, 1, 2. Okay. Wait.
Pythagoras.
Wait. No, other way around. Because it's an equilateral triangle.
Equilateral. Okay.
Okay.
Much better. Okay.
And this is 2, 2, 2.
Pythagoras.
Wait, 4. Wait. I'm really coughing.
Okay.
Wait, why am I? Okay. Wait. Give me a chance.
Okay.
1 square. 1 square root c. Oh yeah, I mean just c is square root 4 minus 1.
Geometry. Yes. Okay.
So then cosine 30, which is over hypotenuse square root 3 over 2.
Very good. Square root 3 over 2. So you got fraction over fraction. Some students find it confusing to deal with. So oh, you know this? Okay. Yes. The
Oh, I
fraction.
mean, wait.
What you can do is you can times
3.
2 over 2 and times 6 over 6. So
Oh.
the 2 kind of cancels away. Okay, maybe I write it as the super neat fraction. The 2 will cancel away. The 6 will cancel away. Then finally, essentially the 2 goes up and the 6 goes below. So you're left with 0 minus 2 pi over 6 root 3. Okay? Don't need the 0 lah. Can? Exact value, okay? Moving on. Pi over k multiplied by, what's tangent pi over 6? You want to draw a triangle again? Come on, I teach you calculator trick. Okay, calculator trick. Step 1, type in this in the calculator. Then put a pair of bracket, square.
Okay.
What do you get?
Well, I can just get the triangle.
Okay.
It's just tangent opposite 1 over pi 3.
1 over what?
1 over, I mean 1 over square root 3.
Okay. Minus?
Oh, 60. So, opposite, pi 3.
Pi 3? What pi? Tangent pi over
I mean
3 is 60 degrees.
I mean square root 3, not pi 3.
Square root 3. Okay, very good. Pi 3. Okay. Good. Then we want to solve for what? Solve for k, right? But k on the denominator, so I will cross multiply. This k goes here.
Okay.
It remains. Anything to cancel away on both sides before you multiply in the bracket?
Cancel away. The 2 and the 6. I mean,
Okay.
that's not on both sides. But
yeah, that's a good thing to think of.
Then the pi
I'm
can
just gonna straight away change it to 3.
the pi can cancel both sides.
Very good. The pi, that's what I was looking at. Pi cancels away. Okay, very good. So now you're left with negative k over 3 root 3 equals to whatever's in the square bracket. Make k the subject, just have to multiply by cross multiply by what?
Multiply by -3. I mean, yeah, -3 times pi 3. I mean, square root 3. Oh my.
Root 3, square root 3, yes. Then you have to distribute, okay, distribute, and let's see what happens. First term, 1 over root 3 times -3 root 3. Let's just write it down step by step. Minus times a minus becomes a plus, then 3 root 3 times root 3 square. Okay, what do you get? Cancel.
-3 plus 9. So 6.
9. So 6. Exact value of k is 6. Can solve this kind of question? Can. Just remember your 30, 60, 90 and 45, 45, 90 triangles and how to convert between radians and degrees. Okay. Oh, you see, this question very evil. All the topics you learned before are coming back on you. Square roots, tangent, sine, cosine, integrate secant square, quotient rule, trigo identities, everything coming back to haunt you. This is the reason why you have to learn all that before you start doing integration, differentiation. Okay. Finally, question 6. Okay, I have to go a bit faster. This one I go through fully. Yeah, let's go through this. So again, part 1, you have to prove the derivative equals to that guy, and then part 2, you have to solve. So let's just do the same thing. Part 1, differentiate this guy, show that it's 2x ln x plus x. So let me show you this. There's a product going on, x squared multiplied ln x, so you have to use product rule. So keep one, differentiate the other. Differentiate ln, you get what? 1 over x. Plus or minus? Plus or minus?
Plus or minus plus.
Plus, very good. Product rule. Then you keep the other, differentiate the first one. Differentiate x squared, you get 2x. Okay? I'll just put a pair of brackets to be safer. And maybe it's safer if I write it as 2x ln x. Plus this one, x squared over x. Anything to cancel? Can. One copy of x. So you're left with just, maybe I use a highlighter to make it neater. You're left with just x plus 2x ln x. Okay so far?
Yep.
Sure. Okay. Good. How about part 2? Part 2, let's see. Hence, you want to find the exact value of k such that the integral equals that other integral. Okay, how? So what you need to realize is that this is the same thing we've been doing so far, right? Let's just write down the conclusion from part 1. Even if you cannot solve the derivative in part 1, hopefully you can. You should be able to use it to make the conclusion that if you integrate both sides, lazy notation. Integral and derivative cancel away. You're left with just x squared ln x equals to integral of 2x ln x plus x dx. And a plus c. Just to make it look neater, I will swap. Write this like this with a plus c. Okay? So let's take a look at the right hand side. Look at the equation here. What do you see? What do you see on the left hand side? This is all.
This is the same.
Almost, not exactly. Take a look. The only thing we can conclude.
Or the 2x. Wait. No, the 2. Wait.
And got a plus x.
And the x.
So that means that we need to do more work. Over here, we only got x ln x, but over there we have extra
2
factor of 2,
and
extra
plus x. Then
So we need
how?
to do a bit more work. Over here, when you have something plus something integral, what can you do?
Factorize.
Not really
Wait,
factorize. You can
Wait,
factor
what
out
you-
the x, but what I meant for you to do is to see that x ln x, x ln x, you want this as the subject.
Okay.
So you don't want the plus x. This one very irritating. I don't want to.
Yeah.
I don't want it to bring it.
Separate the terms.
Yes, separate the terms. If you factorize, it's not gonna help you. You're gonna end up bringing the yellow color x into the x ln x, which is not so good. Okay, so you separate the terms, make sure the integral and dx happens twice. First pair, second pair. Okay, then get x equals to right hand side. Very good. Now, can we simplify this fellow here, the red color one? Can, right? Integrate x, just x squared over 2. Can? How about this guy? Why did we even split it in the first place? We are trying to solve for what? Light blue, right? X ln x. Over here, what is this x ln x? Almost, but off by a factor of. Is it integral of x ln x? Off by a factor of 2. So what do you want to do with the 2?
Bring out.
Bring out. So you get in 2 times integral x ln x dx.
That is the same.
Very good. Then finally, we have something that's exactly the same. We can finally use this identity. So if I just make x ln x the subject, what do I get? I'll get the following. I'll just drop the plus c for now, because later we're gonna do definite integral. The c will cancel away. We're gonna minus x squared over 2, the factor 2 up still there. Then finally, if we solve for integral x ln x, we just need to divide by 2. Or in other words, we multiply by a half. Okay, so far? Following? Can? So it's just the same procedure as what we've been doing so far. Differentiate. The integration is the reverse of differentiation. So you just have to work backwards. But you need to do a little bit more work because over here it's integral of a sum. So you have to split it first. And the reason why we know we have to split instead of factorize is because we want x ln x. Okay. So always look at the end goal. What do we need? We need this. Or what we want. Want to find. So this is what we have. How do you bridge the gaps? How do you go from what you have into what you want to find? That's a key problem solving strategy. Spot the difference or spot the similarity. Here the similarity is the light blue, difference is the yellow. You only want the blue, you don't want the yellow. If you factorize, you're gonna make things worse, right? You're gonna factor out, you get 2 ln x plus 1. That's going further away from your goal. Okay? So if it doesn't help you with achieving your goal, then you just don't do that. Instead, you be creative and realize that, you can split it. Have to be a little bit creative over here. I mean, it's not such a big step, just have to split it. Okay, then anyways, you get this as the integral. So we're gonna use that. As a result, over here, we have an equation where we have a k that is unknown we need to solve. Right hand side, do you think we can do anything? It's like a constant raised to a power of 6 times k. K is a constant, 6 is a constant. So e constant to the power of a constant times constant over constant square multiplied by constant times constant to the power of constant minus constant. You think we can do anything?
Uh,
The right hand side? The answer should be a no.
yeah.
Nothing to do. So just ignore it. Nothing to do. Ignore for now. Okay, ignore for now. Focus on the left hand side. This one got something to do. Something to do. Upper and lower limit need to substitute, then put a minus between. So let's just do the left hand side first. Left hand side here, we already know the integral will be this fella over here. I factored out the half already. So I can just put in the limits. X equals. What is the x equal to? Let's see, e power 7, e power 6. Wow. Got e power. Does it matter? Doesn't really matter. Just substitute accordingly. Don't be scared of it. Just sub in only. So the half factor out, we can just copy down the half again, multiplied by open bracket. Here, do you know what do you understand that when there's a subtraction going on, like two terms. You just have to treat this as one thing and then minus the second thing. Does it make sense?
Okay.
Okay, can. Maybe here I don't use round, I use square bracket. Then I'll just sub in. So here's how I do it. X square, I sub in with e power 7. So it becomes e power 7 square times ln of e power 7 minus e power 7 square over 2. That's my first term after I sub in the upper limit. Okay, can. Minus, I now draw my second pair of brackets. This time I just replace the e power 7 with a e power 6. Okay, everywhere there was a 7, I erase, change it to a 6. E power 6, e power 6. Okay so far?
Okay.
Very good. Continue simplifying. What we get? Half multiplied by e power 7 square is just e power 14, right? What's ln e7? Ln times e, ln of e power 7. What's that?
It's 7.
Very good. It's just times 7. So I can rewrite it as 7 e power 14. Okay. Minus, this is just e power 14 over 2. Nothing to do. Very good. Minus away, open the bracket here because this pair of bracket actually is optional. I don't need to put anymore. Okay, this pair can drop. This second pair are not optional because minus need to bring in. I'll do it later. Let's simplify this first. Same thing. 6 times 2 is now 12. Ln e, they will cancel away. So it becomes a 6. I'll just put a 6 in front of the e power 12. Minus away e power 12 over 2. Okay so far? Very good. Bring in the minus sign. So we get the exact same thing, but just change the sign. This becomes a minus 6 e power 12. This one becomes a plus e power 12 over 2. Very good. Erase. Okay, anything to simplify? Any like terms?
I mean the e power 12.
E power 12 here, e power 12 here. Anything else? How about this part? E power 14, e power 14. Okay. So actually what we have here is a 7 and a minus 1/2, right? 7 minus half is?
7 minus half is 6.5.
6.5 e power 14. Okay, half in front, square bracket. Then here you have minus 6. Let me highlight it. Minus 6 plus half. What's minus 6 plus half?
Isn't that just minus 5? Wait.
Yes,
Yeah,
minus
minus
5.5 e power 12. Very good. Okay, then we are done. Let's take a look at the right hand side. What do we actually need? We need this to be equal to this funny expression over here. Okay, this funny expression over on the right side. Okay, why does it look so different? Something is wrong. What is wrong? Here got 13, here got 11. Okay, how? Here outside there's a factor of e power 6k. Maybe that's when we can work on the right hand side. We expand this. So what do we get? I'll just leave the 1 over k square alone first. Then multiply e power 6k inside. Is that okay? Okay, so we end up with 13 times e to the power of 6k plus k, so it's 7k, minus away 11 e power 6k. Can?
Yeah.
Can you see what is the value of k now? If still cannot, then don't worry, expand again. I think it's easier that way. Just expand everything term by term. So we end up with 13 over k square times e to the power of 7k minus 11 over k square times e power 6k. Left hand side, just expand. So we get 6.5 over 2 times e power 14 minus 5.5 over 2 times e power 12. Let's simplify. 6.5 over 2, what is it? 3.25. E power 14. 5.5 becomes 2.5 plus 0.25, so 2.75 e power 12. Can you help me calculate what is 3.25 as a fraction? What is 3.25 as a fraction?
Yeah.
2.75 is 11 over 4.
3.25 is 13 over 4.
13 over 4. Okay, very good. So now you start to see a pattern. Can you tell me what is the value of k now? Values. No, value, one value only. Compare and contrast. Can see the pattern?
2,
Minus 11, minus 11.
2. K is 2.
Ah, k is 2. Oh, very good. Yes. Can it be negative 2? You see, here got k squared. If k is negative 2 squared is 4.
Because 6 times negative 2 is negative 12.
Very good. Yes, 6k and 12. You need the k to be positive. Okay. I mean, 6k equal to 12, there's only one answer. Positive 2. Okay. Interesting question. That's it. Now, crash course. Okay, I have 10 minutes. Let me just introduce to you the idea of area under a curve. Okay, so here, let's say that we have this straight line. This is, let's say, y equals to, let me think of a good function. Okay, I think it's 12x plus 2. 12x plus 2 should be good. Actually, that's a bit too steep. I'll just put 3x plus 6. Okay. Okay. So let's plot a few points. Here is, let's say, 2, 3 times 2 is 6, 6 plus 6 is 12. And here, let's say, is 8. 3 times 8, 24, 24 plus 6 is 30. Drop a line down, drop a line down. What shape do you see over here? What shape is this?
Quadrilateral.
More specifically, these two sides are parallel, so it's actually a trapezium. So area of trapezium, I hope you know that it's just equals to half times sum of the parallel sides multiplied by the perpendicular height. Okay? Okay, right? This is L1 parallel L2. Okay? Just a trick, What you're really doing is you're splitting it into two triangles like this. Triangle here, half times base times height. Triangle there, half times base times height. Okay? But this is just a shortcut to make things a bit faster. So let's use this shortcut to make things a bit faster. Half times sum of parallel sides. So what's the height over here? What is L1?
L1 is 12.
12, exactly. What's L2?
L2 is 22.
Huh? L2 is this vertical. This point here is B, 8, 30. X equal to 8, you get 30. So what is L2?
30.
Yes, it's just 30. Very good. That's it. No trick questions, just a simple question. And then perpendicular height is over here. It's just that the height is like slanted here. So this is just 8 plus 8 minus 2, which is 6. Coordinate geometry must be strong now. Need to go and recap your geometry, okay? Coordinate geometry, if you're not okay. 42 divided by 2 is 21. 21 times 6. What is this? 126 unit square. That's the area. Let me show you a different way to find the area, the definite integral. Okay. So what we're gonna do is this area here, I'll just label it as A, is actually the same as the function 3x plus 6 dx, but you integrate from where to where? Make a guess. Where to where? X equal to what to what?
X equals to, okay, I mean 2 and 8.
Exactly, it's just 2 and 8. Let's see if it works out to be the same answer as what we got using geometry 126. Let's see. So integrate 3x, you get 3x squared over 2. Integrate 6, you get 6x. Draw a pair of square brackets. X equal to 2, x equals to 8. Can? Good. Substitute in. So 3, 8 squared over 2 plus 6, 8. Bracket, bracket. Minus. Copy the same thing, but replace the x with a 2. Replace the x with a, sorry, the 8 with a 2. Okay, type in a calculator. What do we get? Let's see. I am calculator 8 squared 64, 364, 180 plus 1292 over 2. This is 8 over 2, 4. 100 minus 4, 96. Very slow calculator. 6, 8, 48. Minus away 2 squared 4, 3, 4, 12, 12 over 2, 6. 6, 2, 12. Okay. Let's see. 96 plus 48. That's 100 plus 48 minus 4, 144. 6, 12, 18 minus 18. 44 minus 14 minus 4. That's 130 minus 4, 126. Ta-dang! Same answer. Coincidence? Is it a coincidence?
Nope.
No, it's not a coincidence. It's because of let me show you. Let me share a screen with you. I'll send you a link as well. Give me 10 seconds to find the link. Hold up. Where did I save it? Aya. Where did it go? Okay, I just sent you the link. You can also open it up on a laptop if you want. Okay, so let me see, what were the settings that I planned for? Okay, I think I'm not gonna use that. Let me see. 1a equals. Give me a second to plan this. Where is my function? Oh, okay, a equals to 2. Okay, let me share screen. Okay, let's take a look. Can you see the share screen?
Yeah.
You know? Okay, close this. What's going on over here? A lot of things going on. This is Riemann sum. It's already a topic in H2 math, but I just want to introduce you to it. So this is the black color line here. Okay, you can't really see it, but this black color line here is 3x plus 6, okay? Y equals 3x plus 6, what we just discussed. Let me change the scale to make it look a bit nicer. Let's just go from 0 to, what's that value, 8, right? Let's just go to 10. Okay, so it looks something like this. If you change the value of A, it will move this blue color line left and right. So over here, A is 2, you can move it a bit more. Let me zoom out a bit to the right, a bit to the left. Okay, you will stretch it. Can you see the animation? Can see, right? Let's just set it to, what was the value? We chose 2. A is known as the lower limit, the vertical line. How about B? Do the same, You can move it to the left, move it to the right. Let's see what happens if I move it to less than 2. You see, it disappears, the area. There's actually a hidden area over here. But now this guy is negative because you're going in a reverse direction. But that's the geometrical way to interpret it. If you find that confusing, you can always go back to the swap the limits of the integral. You introduce negative sign idea. Okay. So anyways, let's just set it to 8 first. How many rectangles do you see? How many rectangles? Can you see? There's like one rectangle here.
2,
I cannot draw straight.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
12. Where do you get the 12 from? if you scroll up and down over the left side, what you realize is that, oh, it's referring to the n over here. Okay, let's just reduce it to 2 rectangles further. So with 2 rectangles, this is what we call approximation, under approximation of the area of this rectangle. What you see is that there's a lot of gaps here, white color gaps, right? Triangles. And you can actually get the exact area of these 2 rectangles. If I am not mistaken, okay, hold on a second. No, they didn't provide it, sorry. Oh wait, they did, sorry. Yeah, they did. Okay, the area of these 2 rectangles is actually 99. You can see why, right? Because if you take 2 to 8 and you split it into 2 rectangles with equal width, this is essentially 6 divided by 2. So this is length 3, and the height is 12. I know it's not drawn to scale, the 3 is longer than the 12. Can you see? The 3 here, it's another 3 here. And this height here is 12, this height here is 21. So if you do the calculation, 3 times 12 plus 3 times 21, you end up with 99. Okay? 99 over here. So what happens if you increase the number of rectangles? Let's see. Let's see what happens if we increase the number of rectangles. If I increase the number of rectangles now to, let me think, 3 rectangles. What we'll get is, now it's 108. Because the height is different and the width is different. Now it's, instead of 3, 3, it becomes 2, 2. Oh, sorry, 2, 2, 2. Length 2, length 2, length 2. Does that make sense? Right. And what happens? The number of white color triangles increases. It becomes 3. Oh, get rid of this. It becomes, where's my pen? It becomes 3 of them, but the area of each of them becomes smaller. And overall, the total area of these white triangles actually becomes smaller. Can you see that visually? So what do you think happens? Okay, can you see that? The white color area, it becomes smaller. The sum of the areas, sorry. So what do you think will happen if I increase the number of rectangles? What happens to the white color area, the sum of the white color areas, the gaps?
Less.
Smaller. What happens to the green color area?
More.
More. But will it go more and more and more? Will it go to positive infinity? No, right? It will just keep on increasing. In this case, let's take a look. I can increase it from 2 to 3. Maybe I don't set to such a big number. Let's just stop at 10. 1, 2, 3, 4, 5, 6, 7, 8. You can see, right, what's going on?
Yeah.
The gaps are getting smaller and smaller. Eventually, if I set this to a very, very big number, let's say 20, okay, the gap becomes so small that it eventually becomes the exact area under the curve, or what we call, the curve in this case is a line, actually 3x plus 6, but we just in general call it a curve. Let's take a look at the approximation here, 123.3, right? This is the sum of the areas of the rectangles. If I now increase it all the way to, let's say, 50, just now 123.3, now it becomes 124.92, right? It's increasing, but it's getting slower. The increase is slower. Right? It's only plus 2. Just now 123, now 124, is it? But if I increase all the way, let's say 100, wow, you practically cannot see the tiny gaps already, right? It's almost exactly the same. And take a look at the value of this approximation. It's 125.46. And if you look at your working that I wrote down for you just now, the exact area is actually how much? Exact area was how much? Do you recall?
Oh.
Didn't record down. It's actually 126. Why? Let's just calculate it now again. Let me plot the points first. Okay, a point here and a point there. If I can get the point, right? So what this means is this height here is 12, this height here is 30, this base perpendicular height is 6. So the area is what? Half times 12 plus 30 times 6, which is how much? 126. Look at this approximation. It's getting so close to 126, right? Can you see?
Yeah.
So if you increase it all the way to a lot of what we call infinite number of rectangles, just not go too far, 200, you realize that it's getting closer and closer towards the correct answer, which is 126. Now it's 125.73, 0.73, 0.73. Now I increase it to 500. Now it's 125.892. 0.73 jump to 0.892, only plus 0.1. It's getting slower, right? The increase. Eventually, if you add more and more rectangles, this I will eventually be exactly equal to 126. Does that make sense?
Yeah.
Yes, huh? And by the way, this is what we call the Riemann sum. Okay, you don't need to know this, but it's this is how we approximate the area under a curve. And it can be mathematically proven that this guy here is eventually going to be exactly equal to the integral. After you take a limit as n goes to infinity, it is by definition exactly equal to the integral, which is what we are doing. Look, this summation looks like this sigma here, what we call a sigma notation. It looks like the S, right? Integral. And this W here stands for the width. It's like a dx, right? Can you see that? And this F in the middle is like your f of x. Can you see the pattern? Then we have this I equals 0, I equals n minus 1. That's a bit like your lower limit, your upper limit. Similar. Can you see how the notation looks the same?
Yeah.
Yeah. Okay. So for now, because this is not uni math, you don't need to know the reason why. You just need to memorize for me. Definite integral of f of x from lower limit to upper limit will give you the exact area under a curve. It doesn't have to be restricted to a straight line. Okay. It doesn't have to be restricted to a straight line. I can change it to any other line or any other function. Let's say I want what function do you want? What's good? Maybe x squared. Whoa, what's this? Take a look. 167.64. Okay. How do you find the exact area? You just have to integrate. Okay. So integrate what?
From x from 2 and 8 from x
Yes,
equal to
from,
x equal
to the 8 and of what function?
of x squared.
X squared, then d
X.
Yeah. dx. Okay, good. This will give you the exact area. Let's just calculate it straight away. X squared, integrate, you get x cubed over 3, sub in the 8, sub in the 2. So in this case, 8 cubed over 4, 24. Sorry, 8 cubed is not 24. 8 cubed over 3 minus 2 cubed over 3. Let me get my calculator out and calculate this. What would this value be?
64.
It's 168, right? And look at the approximation here.
167.6.
You see, you approximate it with a lot of tiny little, very thin strips of rectangles. It will eventually be exactly equal to the exact answer of 168. 168. Okay, 10. But now let's do something funny. What if I now have a function that goes below the x-axis? Let's take a look at what happens here. If I go below the x-axis, for example, negative x squared. Whoa, what happens? What happens? The color change, right? Look, before,
Red.
after. Before, after. Green is go, red is stop. Okay, green is good, red is bad. Green is positive, red is negative. Okay? Below the x-axis, the area will become negative. Let's take a look at the I value. Hey, what's this? Negative sign. Can see? Negative. Okay. So you just need to memorize this for me. I'm sorry, you have to memorize. When it's area that's below x-axis, the area will be negative. Okay? Okay. Then okay, so now let's see. If you have y equals, let's say x squared, and then let's say you have y equals to, let's say x, maybe 2x. Okay, then let's say that I want to find the area in between. The area in between. Can you see this region over here? How would you find the area? How that you know the definite integral?
Okay, you have the 168 minus 168 minus the 168 minus the trapezium area.
Minus away that trapezium area right below. So maybe give me 5 seconds to copy this sketch. Maybe I need more than that. 30 seconds. Okay, I'll switch over to my iPad. Okay, so here's the graph of y equals x squared. What else we need? We need a graph of y equals, what's that function? Let me check. 2x. Okay, something like this, y equals 2x. They intersect over here. Then let's say we, actually let me take a look at the intersection for that. If x, okay, x equal to 2, let me double check this. Is it the same? Oh, what a coincidence. This is x equal to 2. Okay, then let's say that we have here positive 8. Then let's label the coordinates. You can use coordinate geometry to figure out the coordinates of those point of intersections, right? Right. This will be 2, 4. This will be 8, 8 square, which is 64. This will be 8, 2 times 8, 16. Right? How do you find the, my question was, how do you find the area of this part here? This is not a normal triangle because this part here is curvy. Okay? Curvy. So the solution is, what I would do is I'll label the parts. So let's say this is A, this is B. Okay, 2 parts, A and B. So what I do is A plus B, I know that the total area is really just the integral of the x squared from 2 to 8. So do a bit of work, you get 168. Okay. But B itself is easy to find because it's a trapezium. Okay, trapezium area, I'll just put it at the side. So it will become half times sum of parallel sides times the height. In this case, what's the height? 6 over here. What's the parallel sides? The length here is 4, length here is 16. Right? So I'm sorry. So 4 plus 16. In this case, that would be 20 divided by 2 is 10. 10 times 6 is 60. Okay, unit square. And therefore, if you want to solve for A, it would really just be A plus B, then you minus away B. Does that make sense? Can, right? A plus B is total minus away the B. So that means it's 168 minus away the 60, which is 108 unit square. Oh, wait, is there a faster way that we could do this? Or a different way to do this? Can you see that the area A is really just A plus B minus away B, which is essentially the area under y equals x squared. And B is really just the area under y equals 2x. So the area A is really just the area trapped between two functions. Can you see that? 2x, or maybe I color code it with x squared is on top, then 2x is below. Okay. So this is really just the area trapped between top and bottom function. Can you see the pattern? Top is purple, bottom is that orange, reddish orange. Can you see that pattern?
Yeah.
Can So in general, this area A, right, is really just, if you express it in terms of integrals, it's just the integral of the top function dx from the limit being the same 2 to 8 minus away the integral of the bottom function dx from 2 to 8. Or another way to put it, integral from the same limits 2 to 8, top function minus away bottom function dx. The top in this case being x squared. Yeah, this guy is x squared, and the bottom here being 2x. If you integrate 2x from 2 to 8, you will get the same answer of 60. This is exactly the same as integral of, what's the function? 2x from 2 to 8 dx. Can?
Mm-hmm.
Can verify quickly. So x integrate, you get x squared over 2, bracket, and 2 to 8. 2 cancels away before you sub in. So 8 squared minus 2 squared. 64 minus 4, which is 60. Okay, can? This is a very important idea. This one. This is the key idea you must take away. Area trapped between two functions is just equals to area of the top function. It's just integral of the top function minus the bottom function, but from the left to the right. Okay,
Mm-hmm.
can? But what happens if it goes below? What happens if the function goes below? So for example, yeah, it will be negative. Answer is negative. So let's quickly take a look. What's a good function? Let's say we have y equals negative x. Let's say this is 1. Let's say this is 5. X minus 1, x minus 5. Expand this, I get negative x squared minus 1 minus 5 is minus 6. Plus 5. Distribute, I get minus x squared plus 6x minus 5. If I integrate this y function from, let's say, what is this? Let's say this is 1 plus 5 is 6. 6 divided by 2 is 3. In the middle here is 3. 3 comma something. In this case, if I go a little bit to the left, let's say here 2, and then here is x equal to 0. If I want to find the total area of this part and that part, maybe I label it differently. I label this as region A, region B. Can you see the region A and B?
Mm-hmm.
This part here and that part there. So how will I find the area of A and B? Can I just integrate from 0 to 2? Is that the total area?
Then you need minus dot A.
It is not correct. Why? Because I can quickly verify to you that integral from 0 to, in this case, 1, right? Can you see that the yellow region is trapped in between 0 and 1?
Yeah.
Here and here, 0 and 1. Integrate this function, what is it? Minus x squared plus 6x minus 5 dx. This ends up being negative x cubed over 3 plus 6x squared over 2 minus 5x. Sub in upper, lower, 1 and 0. What do we end up with? Minus 1 over 3 plus 6 over 2 minus 5 minus away 0 plus 0 minus 0. Okay, minus. So this is really just, let's calculate this. 3 minus 5 is negative 2 here, minus 1/3, which is negative 2 1/3. Can?
Mm-hmm.
So it's negative. There's a problem here. When the when the region goes below the x-axis,
Negative.
below, it will be what I said over here, negative. But we need the area, which is positive. So what we really need to do is to take the modulus of this entire integral. Modulus of this whole thing. Modulus of this whole thing, so that it will become the positive version, positive 2 1/3 unit square. Okay. So the answer here is a no, because A is below x-axis. Okay, so the proper way to find A plus B is really just find it piece by piece. A equals to the modulus of the integral. Okay, then B equals, because it's already positive, we don't need modulus, just integrate from 1 to 2. Can you see that? Why it's 1 to 2? This region here is sort of like sandwiched in between a left interval and a right interval 1 and 2. Can you see that?
Okay.
1 here, 2 there. Okay, maybe I'll highlight in the same color, 1 and 2. Okay, then you just integrate the same function. So let me copy that function, but with different limits. So a smart strategy that you can do in order to save time is to do an indefinite integral first. Then after that, you try to solve for A and B. Because now you just need to replace the upper and lower limits. Okay, now I just copy and paste this. And then I put in 2, 1. So now it's negative 2 cubed over 3 plus 6 bracket 2 square over 2 minus 5 bracket 2 bracket minus away. Minus 1 cube is just 1 over 3 plus 6 times 1 square, which is just 1 over 2 minus 5 times 1. Okay, then the rest you can just key in the calculator. Let's just do it quickly. Minus 2 cube is 8, right? Never mind, just use calculator. Just use calculator. Plus fraction 6 times 2 square divided by 2 minus away 5 times 2. So the first part is a negative 2/3. Minus away, open bracket. Let's see what the expression is. Minus 1 over 3 plus 6 over 2 is 2 minus 5. This is minus 10 over 3. So that means minus 10 over 3, I have to times a negative 1. Oops. Equals times negative 1. This will give me positive 10 over 3. And then a minus 2 over 3. Which is equal to 8 over 3. That's the answer. Can understand? This is the answer for B. But we're not done because we want total area, so you need to take A plus B, which is equal to 2 1/3 plus 8/3. Okay, 2 3 6 6 plus 1 7. 7/3 plus 8/3, 7 plus 8, 15 over 3, which is equals to 5 units squared. Yay. Oh, 44 already. Okay, then that will be all for today, I guess. We will go through more cases of area under a curve next lesson. Then I'll assign you some homework now. Can?
Okay.
Okay, can. That'll be all for today. I'll send you some homework. Bye-bye.
Bye-bye.
Let me know if you got any questions.